Okay, so for this assignment, I chose to do question 25. A 55 kilogram ice skater is gliding along at 3.5 meters per second. 5 seconds later, her speed has dropped to 2.9 meters per second. What is the magnitude of the kinetic friction acting on her skates? So I started by drawing a free body diagram. And her skates are experiencing a normal force and a force of gravity. And then the question tells us that there's a kinetic friction force, and so that would be opposing her motion skating forward. And then just the little key to show the x and y direction. The skater's velocity, and then the skater is slowing down, so the acceleration will be in the opposite direction. Okay, and then we look at what's given in the problem. And that is that it's a 55 kilogram ice skater. So the mass is 55 kilograms. 3.5 meters per second would be her initial velocity. 5 seconds is going to be the change in time. And 2.9 meters per second will be the final velocity. And then this asks us for the kinetic friction. So we know that we'll be solving for that. And then we know that force is equal to the mass times the acceleration. And currently we have no acceleration. So we're going to want to find that. And we can find that using a kinematic equation from chapter 2. Specifically that the final velocity is equal to the initial velocity plus the acceleration times the change in time. And we have the final velocity, initial velocity, and change in time. So we can rewrite this equation to solve for the acceleration. And that'll be the final velocity minus the initial velocity over the change in time. And if we put in the numbers that we have, it will be 2.9 meters per second minus 3.5 meters per second over 5 seconds. That gives us an acceleration of negative 0.12 meters per second squared. Alright, and then we can use this to find the force of kinetic friction. So, kinetic friction is in the x direction. So we'll write that. So, the net force in the x direction is equal to the mass times the acceleration in the x direction. In this case, kinetic friction is the only force acting in the x direction. So we can write that the negative kinetic friction force is equal to the mass times the acceleration in the x direction. And so we can plug in our numbers there. And that is 55 kilograms times that acceleration that we just solved for. And that gives us negative 6.6 newtons. And we can take off those negative signs to find that the magnitude of the kinetic friction force is 6.6 newtons, and that will be the final answer for this question.